There's a camera trap mounted to a cypress tree deep inside the Florida Everglades. It records everything, day and night, rain and dry season, no matter what moves past it. And recently, what moved past it stopped a room full of wildlife biologists cold. Not because of what the footage showed destroying the swamp. Because of what the footage showed fighting back. This video is not another story about how Burmese pythons ruined one of America's greatest wild places. That story has been told. What hasn't been told, at least not fully, is what is happening right now in the water, in the grass, in the treetops, and in the pine forests 400 miles north of the invasion zone. Because something unexpected is unfolding in Florida. And depending on which side of the biological war you're watching, it either looks like the beginning of the end, or the first real sign of hope in 30 years. Let's go through it piece by piece. Before we talk about what's being lost, you need to understand what's at stake, because most people don't. The Florida Everglades is not a swamp. That is the single most expensive misconception in American environmental history. It is a slow-moving river, 1.5 million acres wide, spreading in a shallow, continuous sheet across the bottom of the Florida peninsula, filtering water, feeding aquifers, absorbing storm surge, and sustaining every living thing downstream of it. It is also worth money in a way that is almost incomprehensible. A 2025 study by the Everglades Foundation and Earth Economics put a number on the ecosystem services the Everglades provides every single year. The figure was $31.5 billion annually. Over 50 years, the total asset value reaches $1 trillion. And the economists who ran those numbers were clear. That figure is an underestimation. The value of the drinking water alone, water drawn by 8 to 9 million people in South Florida, cannot be fully calculated. UNESCO recognized this. The Everglades holds World Heritage Site status, Biosphere Reserve designation, and Ramsar Wetland of International Importance recognition simultaneously. Only 2 other places on Earth hold all 3. The Great Barrier Reef, and the Galapagos Islands. Before the year 2000, the Everglades supported more than 800 vertebrate species, 400 species of birds, 275 species of fish, 36 federally threatened or protected animals. Raccoons were so numerous that park rangers classified them as a nuisance. Marsh rabbits were documented in field reports as superabundant. Nighttime drives along the main park road produced dozens of mammal sightings every single hour. Wading birds rose from the sawgrass prairies in numbers that early naturalists compared to storm clouds. The Florida panther, once pushed to fewer than 30 surviving individuals, depended entirely on this mid-sized mammal population as its primary prey base. Every layer fed the one above it. The raccoons fed the panthers. The fish fed the herons. The frogs fed the snakes. The snakes fed the hawks. It was not a fragile system. It was ancient, layered, and very nearly indestructible. Then a pet store made a decision that changed everything. Through the 1980s and 1990s, Miami became the undisputed center of the American exotic reptile trade. More than 12,000 wildlife shipments passed through the city every year. Between 1996 and 2006 alone, over 100,000 baby Burmese pythons were imported into the United States. They were 20 inches long. They fit in one hand. They sold at reptile expos across Florida for as little as $10. They were marketed as the cool pet of the moment. What the sellers did not advertise was what a Burmese python becomes. A snake that fits in your palm grows at up to 4 feet per year. Within a few seasons, that $10 novelty becomes a 12 to 20-foot animal weighing up to 200 pounds. When overwhelmed owners couldn't manage what they had purchased, many drove to the nearest canal or wetland and released the animals. They told themselves they were giving the snakes freedom. What they actually did was load a precision predator, one specifically evolved for ambushing and consuming large prey in dense vegetation, into the most vulnerable ecosystem in North America and walk away. Then in August of 1992, Hurricane Andrew hit South Florida as a Category 5 storm. A reptile breeding facility near Homestead was torn apart. An unknown number of captive Burmese pythons escaped and disappeared into the wetlands. The hurricane gets the dramatic credit in most retellings, but it wasn't the starting point. Wildlife biologist Ian Bartoshek of the Conservancy of Southwest Florida, who has tracked Florida pythons longer than nearly anyone alive, put plainly, if the origin story were a multiple-choice question, the choices would be escaped pet, intentionally released, or meteorological disturbance. The answer would be all of the above. A 2011 genetic study confirmed that pythons had almost certainly been breeding in southern Florida since before 1985. By 2000, Florida wildlife officials acknowledged a self-sustaining, actively reproducing python population inside Everglades National Park. The U.S. government banned importation in January 2012. Florida criminalized ownership entirely in 2021. By then, the USGS estimated tens of thousands of pythons in the Everglades. Other researchers placed the number between 100,000 and 300,000 animals. Steve Davis, Chief Science Officer of the Everglades Foundation, described the detection problem in stark terms. For every python a person sees in the Everglades, field estimates suggest between 100 and 1,000 others they do not see. In 2012, 11 scientists published a paper that confirmed what field researchers had been quietly reporting for years. The lead author was Michael Dorcas of Davidson College. The methodology was simple. The results were devastating. Dorcas's team drove the 130-kilometer main park road inside Everglades National Park at night, using the same route, the same speed, and the same counting method from surveys conducted in 1996 and 1997. The comparison was direct and complete. Raccoon populations had fallen by 99.3%. Opossum populations had dropped by 98.9%. White-tailed deer were down 94.1%. Bobcats had declined by 87.5%. Marsh rabbits were not detected once during the entire 8-year survey period. Foxes were not detected at all. Not reduced. Not suppressed. Gone. The spatial pattern of the data made the cause undeniable. The worst losses appeared in areas where pythons had been established the longest. Intermediate losses appeared at the edges of python range. At control sites beyond python territory, mammal populations were near historical levels. The collapse tracked the invasion with precision, in both time and space. A controlled experiment published in 2015 removed any remaining doubt. 95 radio-tagged marsh rabbits were released inside Everglades National Park and at python-free control sites. Inside the park, pythons killed 77% of the tagged rabbits within 11 months. At the control sites, python predation was zero. The animals that vanished took their ecological functions with them. Raccoons had dispersed seeds, consumed insects, and formed the core prey base for Florida panthers. Possums had processed carrion across the landscape. The mid-sized mammals that filled the middle of the food web were the load-bearing walls of the entire ecosystem. Researchers who had worked this land for decades described driving for miles through habitat that used to be alive and seeing nothing moving. They started calling it the silence. And once they had named it, the Everglades never felt the same again. Florida did not accept this quietly. The state launched public hunting competitions, deployed thermal imaging drones, set food-baited traps, and eventually paid professional contractors to remove pythons year-round. Every approach hit a wall. The Florida Python Challenge began in 2013. In its first year, 1,600 registered participants removed 68 pythons. By 2025, the record was broken at 294 snakes, removed by 934 participants. Michael Kirkland, who oversees the South Florida Water Management District's Python Elimination Program, described the competition with unusual government honesty. Removing 200 to 300 snakes per year from a population of at least 100,000, he said, functions about as effectively as draining a lake with a soup ladle. Thermal imaging drones failed for a precise biological reason. Burmese pythons are ectothermic. Their body temperature equilibrates with the surrounding environment, making them nearly invisible against the thermal background of a warm Florida wetland. Even visual drones struggle to detect pythons concealed in tall grass. food-baited traps failed because Burmese pythons don't pursue food. They are ambush predators by design, built to wait motionless for prey to come within range. No known attractant exists that pythons will reliably approach. Professional removal programs launched in 2017 changed the scale of the effort meaningfully. Through Florida Fish and Wildlife's PATRA program and the South Florida Water Management District's Python Elimination Program, approximately 100 paid contractors now work the Everglades year-round. In July 2025, a partnership with a Miami-based artificial intelligence company produced 748 python removals in a single month, a number that exceeded entire previous years. The cumulative removal total crossed 23,500 animals by 2025. The most sophisticated tool in the toolbox remains the Judas Snake program. A captured male python is surgically fitted with a radio transmitter and released back into the field. During breeding season, the tagged snake follows female pheromone trails and leads researchers directly to mating aggregations. The females and rival males are removed. The transmitter-bearing snake is released again. Ian Bartoshek has operated the largest ongoing version of this program since 2013, deploying 40 scout snakes across 200 square miles of southwestern Florida. His team has removed more than 20 tons of python biomass and prevented an estimated 20,000 eggs from hatching. In 2023, the USGS made its position on eradication official. Complete elimination of Burmese pythons in southern Florida is, in their assessment, likely impossible. But the pythons didn't arrive in Florida carrying only their appetites. They carried something microscopic. And by the time anyone found it, it had already stopped needing the pythons to travel. Its name is Rallidiella orientalis. It is a pentastomid, technically a parasitic crustacean, roughly 3 to 4 inches long, with 4 hardened hooks built for gripping the tissue inside a snake's lungs. In Southeast Asia, Burmese pythons carry it without serious harm because they have coexisted with it across thousands of years of shared evolution. In Florida, this organism entered a landscape of native snakes that had never encountered anything like it, and it began filling their lung tissue, blocking their airways, and suffocating them from the inside. Dr. Christina Ramagosa, Associate Research Professor of Invasion Ecology at the University of Florida, helped lead the foundational research documenting the parasite spread. Her assessment: co-introduced pathogens and parasites are not often factored into the management of biological invasions, and this discovery adds urgently to what we know about the disease costs of moving animals across the globe. The transmission chain runs through 3 hosts. Adult parasites in an infected snake's lungs release eggs through the animal's waste. Cockroaches consume that waste and carry the larvae internally. Frogs and lizards eat the cockroaches and serve as the next stage of larval development. When a native snake eats an infected frog, the larvae migrate through the stomach wall directly to the lungs, mature into blood-feeding adults, and begin producing a new generation. The critical detail: once this cycle is established, it runs without any python involved at all. A 2020 study of more than 500 dead native snakes collected across southern Florida found that 13 of the 26 native snake species in the region were already infected. More alarming, the parasite achieved significantly higher infection intensity inside native snakes than inside the pythons themselves, growing larger and reproducing more aggressively in hosts carrying no evolved resistance. By 2025, 18 native snake species showed confirmed infections across 27 to 35 Florida counties. The parasite had reached Alachua County near Gainesville, 340 kilometers north of Python. Now we get to what stopped those biologists cold. On a night in December 2022, Ian Bartoshek's team received a transmitter signal from a python they had tracked for 6 consecutive breeding seasons. His name was Loki, 13 feet long, 52 pounds, 6 full seasons of surviving South Florida predators and professional python hunters. When the team reached the coordinates, they found a carcass. Loki had been killed, cached, and partially consumed by a bobcat. The bobcat weighed 25 pounds. A trail camera set nearby had recorded the entire encounter. The bobcat had approached from behind, identified its moment, and taken down an animal more than twice its own body weight. Bartoshek described the find the same way every time he told the story. A 25-pound cat killed and cached a 52-pound python. He called it a win for the home team. This was not a fluke. A peer-reviewed 2023 study was the first to formally document native Florida wildlife predating on invasive Burmese pythons in published scientific literature. The study confirmed American alligators consuming juvenile pythons across multiple recorded instances. Florida cottonmouths were confirmed through radiography to have killed and swallowed young snakes. A hispid cotton rat, an animal that by any logic should be prey, had killed a hatchling python. In June 2021, a trail camera at Big Cypress National Preserve filmed a bobcat raiding an active python nest and eating eggs directly from the clutch. Necropsies conducted by Bartoshek's team found bobcat claws and fur inside the stomachs of adult pythons, confirming the predator relationship runs in both directions. The bobcats were hunting the pythons. The pythons were sometimes hunting the bobcats. And the bobcats were winning frequently enough to keep coming back. What is happening in Florida right now is not only an ecological catastrophe. It is the fastest forced ecological evolution ever documented in North America. The native animals that survived the first wave of the python invasion are not the same animals behaviorally that they were 20 years ago. A bobcat that learned to identify the sluggishness of a freshly fed python as a kill window is a different predator than one that has never seen a python before. An alligator that has encountered hatchlings in the water is a different hunter than one operating in a python-free environment. The animals surviving are the ones finding and exploiting vulnerabilities in a predator they had no evolutionary history with 3 decades ago. They are doing it through learned behavior. They are doing it fast. At the same time, the pythons themselves are being shaped by the pressure. Bartoshek's long-term radio tracking data has documented consistent movement of pythons away from human access corridors over time. The cautious animals survive. The visible ones do not. Natural selection is running on both sides of this war simultaneously. Nobody knows yet which side is running it faster. 400 miles north of all of this, in the longleaf pine forests of Florida's Apalachicola region, something happened in the summer of 2023 that made wildlife biologists set down their clipboards. A trail camera recorded 2 snake hatchlings moving through the undergrowth. These animals had never been touched by human hands. They were born to parents who had been living and hunting entirely on their own terms, without radio trackers, without supplemental feeding, without any human involvement, on land that had not supported wild eastern indigo snake reproduction since before most Americans were alive. Michelle Hoffman, a field biologist with the Orion Center for Indigo Conservation at the Central Florida Zoo, described the moment with the careful language of a scientist working hard to contain something that felt much larger than the words available to her. Finding evidence of reproduction, she said, was one of the biggest markers the project team had been looking for to determine whether the reintroduction was succeeding. She called the footage a big signal. Then she added something that field scientists almost never allow themselves to say out loud. She was not expecting this level of success this early in the program. The eastern indigo snake is the longest native snake in North America. It is completely immune to the venom of every pit viper on the continent. It is a confirmed snake eater, and it was reintroduced into the Florida Panhandle specifically because of what has been unfolding 400 miles to the south. 209 snakes have been released at Apalachicola across 9 consecutive years. The 2025 cohort was the largest single-year release, yet 42 animals. Eastern indigo snakes at and near the release sites have already been observed consuming